And then pause. Okay, let's try this question. Okay, I just came out of it. It's a fresh question. So again, there are two ways to solve this kind of question. Whichever way comes to you first, okay? First way is longer. It's using lines. This is the question I'm planning to add to my worksheet soon. Okay. So I have not thought of how I want to add. Because but I may just add in both. Like we can use lines method to solve. That'll be under vectors 2. Or we can use ratio theorem to solve. That'll be under vectors 1. Okay. So I use lines and solve first. First, let's find AD. So this is just 1/3 of -235. In fact, one of the questions I did was all just in A and B. It's also possible. Okay. So this one is just half of 121. Okay. The numbers are not nice. Numbers are not nice. But I didn't have time to go and think of nice numbers here. So what happens is you can find line AD is actually OA plus lambda of AD. AD is OD minus OA. Okay, so negative 2/3 minus 1, negative 5/3. Negative 1, positive 1, 1 minus 2 minus 1. 5/3 minus 1 is 2/3. Okay, or you can put as 121 plus maybe lambda naught of -5 minus 3, 2. Also can. Okay, may I miss it? Correct. So why is lambda naught? Because I want this fraction. Easier to solve later. Line BC. Okay, we have R equals to -235 plus mu of BC, which is OC minus OB. Half minus -2, 5/2. 1 minus 3 minus 2. Half minus 5. -9/2. You could also do -235 plus mu naught of 5 minus 4 minus 9. Okay, so the numbers are nice. Where mu naught equals 2 mu. Then where lambda naught equals 3 lambda. Lambda over 3, sorry. So this should be lambda over 3, this should be mu over 2. Okay, which doesn't matter, it's just another constant. So to make things simple, so that we are in. So what happens is that this is also OE. So OE is point of intersection. Therefore, we can have 1 minus 5 lambda naught equals -2 plus 5 mu naught. 2 minus 3 lambda naught equals 3 minus 4 mu naught. And the last one is 1 plus 2 lambda naught equals 5 minus 9 mu naught. Okay, you can do a quick check by checking these 3 numbers. These are all these numbers here. Then you can just check accordingly. The numbers are correct. So what happens here? Oh, I used a whole page. Oh, there's a lot of blank above. I missed it. So here, okay, then we can just use GC already. Okay, 5 lambda naught plus 5 mu naught equals, like bring over equals to 3. Equation 1. 3 lambda naught minus 4 mu naught equals 2 minus 3 minus 1. Equation 2. 2 lambda naught plus 9 mu naught equals, then bring over 4. using GC. 3 equations, 2 unknown. By right should solve. Because by right, they will be all on the same plane. So definitely there should be a point of intersection. Okay, if not, most likely it's careless already. So 3 equations, 2 unknown. 5, 5, 3. 3 minus 4 minus 1, 2, 9, 4. Solve. I get lambda naught equals 0.2. Mu naught equals 0.4. So now we will use mu naught. Therefore, OE equals to minus 235 if I use mu naught. Plus 2/5 of 5 minus 4 minus 9. Okay, we just solve for this. So I can take out 1/5 to make it easy. Minus 10 plus 10. Okay, then 15 plus 2 times minus 4, minus 8. Then 5 times 5, 25 minus 18. Equals, you realize that to reduce the fraction, I always take it outside. Just take a scalar outside, it's always okay. So 0, 7, 7. Oh, even nicer. 7 over 5 of 0, 1, 1. So that will be my answer. To check, you'll need to put this into, you can put 0.2 into this to see whether you get the same value. So if I put 0.2, I get 1 minus 1, which is 0 for the front one. 2 minus 0.6, which is 1.4. And 1 minus 0.4, 2 minus 0.6 is 1.4. And 1 plus 0.4 also 1.4. And they are 7 over 5. So this is your correct answer. Okay. So understand this method 1, right? Okay, 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 now method 2. Lucky I do halfway down. So I got space above. So now I use green color to show you method 2. Now, both methods are important because they can ask you to use either method. Okay. So the second method is by using ratio theorem. Means you don't know vector lines. Okay. So it is possible, I mean, for those J1s who haven't learned everything, it's possible for them to test when they haven't learned vectors too. Huh? So what happened is that I can let this be lambda and 1 minus lambda. In other words, let AE equals lambda AD and CE equals mu CB. So this will be mu, this will be 1 minus mu. Because lambda and mu will be less than 1. So it becomes a ratio. Okay, now we are going to method 2, which is by ratio. So for OE case, so for this one, you can just do, okay, follow the diagram, right? So OE, I just let's try to find some space here, is equals, so you see OE is at the center here. Okay, it's at the center here. So now we'll be using AODE here as the ratio theorem. Lambda OD plus 1 minus lambda OA. So ratio theorem, normally you need to sum the two up, but when you sum the two up is 1. So yeah, it's actually dividing by 1, which you don't need to. So it becomes a linear solution that I can just solve. Okay. OD is 1/3 of minus 235. So you have 1/3 lambda minus 235 plus 1 minus lambda 1 to 1. Okay. Yeah. Huh? OD is 1/3 OB ma. Okay. So from here you can find OE. Then you do the same for mu and then you repeat and try and solve. If by right, you should get the same answer. Okay. So minus, so you get 1/3 minus 2 lambda plus 3 minus 3 lambda. 3 lambda plus 6 minus 6 lambda. Then this is 5. 5 lambda plus 3 minus 3 lambda. Minus 2, so you get 3 minus 5 lambda plus 3 minus 3 lambda plus 6, 2 lambda plus 3. Okay, same thing. This is biratio theorem. Maybe you need to add in biratio theorem. Same thing. You also have OE equals mu. So now you have mu OB, 1 minus mu OC. Okay. Mu OB plus 1 minus mu of OC. OB minus 235. OC, there's a half A. Okay, so now I will bring out the half. Minus 4 mu, 6 mu, 10 mu, plus minus mu, minus 2 mu, minus 1. Minus 5 mu plus 1, 4 mu plus 2, 1 minus mu here, forget. So 9 mu plus 1. So this is both OE. Again, we are going to equate them and then we solve. Okay, they are equally long. It's like no, there's no one that's better than the other one. Okay, it may be better depending on numbers. Maybe. Okay, can't tell. But generally, there's no better solution. Both are okay. So for the numbers here, you see both are equally complicated. So here, we'll again have 1/3 of minus 5 lambda plus 3. Equals half of minus 5 mu plus 1. Then we have minus 3 lambda plus 6. Then 2 lambda plus 3. Equals half 4 mu plus 2, 9 mu plus 1. Okay. For this one, this is simplest. This one just before that we have minus lambda plus 2 equals to 2 mu plus 1. So this one will give us lambda plus 2 mu equals 1. This one will be cross multiply, negative 10 lambda plus 6 equals negative 15 mu plus 3. So bring over 10 lambda minus 15 mu equals to 3. Equation 1, equation 2, and cross multiply 4 lambda plus 6 equals 27 mu plus 3. So cross over 4 lambda minus 27 mu break, minus 3. So again, 3 equations, 3 unknown. 10 minus 15, 3, 1, 2, 1, 4 minus 27 minus 3, solve. So using GC, lambda equals 0.6, mu equals 0.2. Okay, so now you can, now with this, you can find OE. You can sub inside. We just use lambda 0.6. So OE equals to 1/3 negative 5 times 0.6 is what? 5 times 0.6 is negative 3. Negative 3 times 0.6 is negative 1.8. 2 times 0.6 is 1.2. So plus 3 plus 6 plus 3. 0. 4.2. 4.2. Huh? Can? (4.2) is 21/5. So you get 21/5 times 3 of 0.11. Yeah, so you get the same thing. 7/5 of 0.11. I mean, you can leave it as here also. Okay, I just need to show that it's the same thing. Questions? Y'all can do means you remember the lesson. Good. If it's the same one come out, y'all be so happy. Any questions? Any questions here? Yeah. Okay. I'll pause it here. So expert already now can go to, we did until question 5. Have you all tried 6? Okay, only who haven't do? I forgot to mention there's homework also. Yeah. Only time we now let me can try first. I know you do it already. We'll go through something. Okay, can so I give you a few minutes to look through.